So let's go ahead and take a look through the player controller script. I left out comments on purpose because I thought it would be easier to code and less confusing for those that wanted to just put that in their game and be done with it. But for those that want an explanation, I'm going to go through and put in comments. So comments are not actually run by the compiler. They're just used to talk about and explain what's going on in code. So to put in a comment, there's a couple different ways. For just a single line comment, you use a double slash. So notice it turns gray. So you type in anything in there and then it's just a comment that explains what's going on. So at the very top, you have your import statements that allows you to use different classes. And for all intensive purposes, a class is just an object. So for example, we're creating a class that represents a player object. So there's only ever going to be one in the scene. So that's why this script is only attached to the player. So notice the squiggly brackets. So that shows where something is opened. So this squiggly bracket, whenever you open the class, you also need a closing one. So notice this is highlighted down here. Whenever you put your cursor close to a squiggly bracket, it's always going to show where the other one is. For example, if I put my cursor here, it highlights this one here, which is close to update. So we have three variables that we're creating at the top. A float represents a decimal variable. So we're creating a move speed variable that represents how fast we want the player to move. Okay, so I'm just going to put in a comment up here, player speed. Let's actually do this, movement speed. All right, the next one is also another decimal variable, which is the player jump speed. Eventually, I was thinking about maybe putting in a jump application that isn't in effect till later. This is the terrain drag. So for example, if they were on sand or something that was a little bit more sticky, the drag would be decreased so that the movement speed was not as fast. So this just allows for a little bit more interactivity with the terrain and the game world. All right, so right now I have set that set as 1. All right, so the update function, this is being called every frame. Every frame of the game, which on most PCs is around 60 frames per second, you're creating a vector 3, which represents a position in space in 3 dimensions. So if I hover over here, it gives you a little tooltip. Represents 3D space. So you have your X, your Y, and your Z. All right, so that's all this does is creates a variable that's going to hold a position, and it's called direction. That's going to be used later. All right, so let me put in my code for that. All right, same thing's happening on the next one, but now this vector 3 is being set to the forward position of the camera. So we're grabbing the object dot, and now it's grabbing the property of the camera. So we're grabbing the main camera, which is our only camera in the scene. It's grabbing the transform component. So for example, if I model that by going into my hierarchy panel and clicking on the camera, here is what the code is talking about, the transform component of the camera object. It's then telling that the transform direction that is forward is going to be whatever the forward front-facing direction is from the camera. It's then going to set the Y position of that forward direction to 0. So we want it to be on the same axes or flat axes as the camera. All right, the next vector 3 goes ahead and applies a forward force. So it's multiplying the vector, so the direction, multiplied by, and now this is a class that gets input from the keyboard, and it's getting the vertical axes. So that's either W or S or forward and backward on the keypad on the keyboard. It's getting that direction, so this is always a value between 1, which is positive, so that means all the way up, and -1, which is all the way down. So it's multiplying the forward vector, depending on whether they're pressing forward or backward, and then multiplying it by the terrain drag. Normally this is 1 for normal terrain, so this really doesn't affect it unless they're on some type of sticky substance, or maybe they're on a boost where they can go a little bit faster. All right. This vector is doing a very similar thing, but now this is in the horizontal direction rather than forward and backward. So this would be left or right. And for lack of a better word, I just called it right. So it's doing the same type of idea that it's doing up here and forward, but now it's setting it to the right, which would be 1, and setting the Y position to 0. Then similarly, we have the right force, which is taking its left and right direction, getting the axes in the horizontal, so it's either left or right, and multiplying it by the drag. The last two if statements is a check for certain key codes or key presses on the keyboard. So D or A is going to be the same as the left arrow or the right arrow. So this is all going to do the same thing. So if it's pressing left or right, it's going to change the direction and add in the right force, which in this case, we have set it right here to be positive or negative. So even though it says right force, if they are pressing left, it will go left. In a similar fashion, we're doing the same thing with forward and backward. It's going to take that direction vector, depending on which way the ball needs to go, it's going to add in the forward force. Now that we have that vector inside of a variable, we can now apply that to our rigid body. So the whole idea before, when we set up our player, we put that rigid body on it so we can apply physics. So in order to do that, we have to apply forces to it, telling it to move. So we're getting the rigid body component dot applying the function that says to add the force to it, and then we're telling what the direction is, which is the same variable that we used up here. It's normalizing it, making sure that it's between 1 and -1, and then multiplying it by however fast we want to move it. In my case, I've used a value of 6, and then also multiplying it by the drag. All that is happening every frame in the game. So obviously this is running very, very fast. But these are quick calculations for the computer to do. Moving on to the mouse orbit script, this one is a little bit more complicated, but it's also a little bit longer. All right, so in this case, we have more variables that we're using. So we're holding on to a target transform, so which object is the script supposed to be following. We have a decimal variable that represents the distance, how far away is the camera from the actual object. We have a decimal that represents how fast it goes left or right, how fast it goes up and down, and then it's also the limits. How far can it go up or down? That's the min and the max. And then we have private variables here that are not actually used in the editor. These are private variables, so you cannot edit them, but they are used in calculations. So this is the actual X and Y angle of the camera. All right, and then we have an invert, which for some people, especially like my brother, I know they like to invert the mouse, so I threw that option in there. In terms of our functions, we have one function that's called start. So this only gets run at the very start of the game. So it happens one time. It's going to create an angles variable that sets the angles equal to the angle that the camera is oriented. Same thing for the X and the Y axis. It goes ahead and sets the cursor so it's locked in the center of the screen. I'll leave you guys to put in the comments as I'm going through here. This one sets the cursor so it is not visible. So while it's locked in the middle of the screen, this one's going to make it invisible so you're just focused on where the ball is. Our next method is late update. So this function runs similar to update, but it runs after the actual update function. So now you're probably asking, well, where's the regular update function? Well, we don't have any. So we want this to happen after the player is moved. So this update function is actually ran first, but then this function is run. And this one runs after this one because the angle of the camera depends on where the ball is at. All right, so similar to what we have in the player controller, we're taking our X value of where the camera should be, and we're getting the mouse X, so it's moving left and right, multiplying by the speed, and then also multiplying by 0.02. So this is just a set value so that it slows down the camera a little bit. Same thing happening with the Y value, but notice this line right here. This is just saying, is invert true or false? If it's true, then we want to invert the way that the mouse direction goes up or down. So set it to -1. If it's false, it's going to set it to 1. This one is a little bit tricky, but since we've been through a little bit of coding, it shouldn't be too bad. So it's taking the Y value and setting it equal to, and now it's running this function. So it's going to call clamp angle. So we jump down here to clamp angle, and it's going to take in what angle it's trying to clamp, And all it's going to do is prevent it from going outside of the min or the max. So if it's less than the min, it's just going to reset it. If it's greater than the max, it's going to reset it, so on and so forth. So it allows us to keep the angle between negative 360 and 360 degrees. That's all. And then it returns that value. Next one, we have a rotation. We never want to rotate the camera around the z-axis. So all this line is doing is setting it so that value is 0. And we're setting the position of the camera, so it's going to be the same distance away from where the marble is, plus where the position is. And lastly, we're going ahead and setting the rotation in the position. Okay, so without these two lines of code, the script would be totally worthless. So we need these two to tell it what rotation it should have, and this is our stored variable, which was created right here. And we have our position, which was created right here. So that was a quick rundown of what the code looks like. I just wanted to give you that brief run through in case you guys wanted to change some things, or we're definitely going to change some of this in the future. So I wanted to give you a chance to run through the explanation, put in comments if you needed to, and have that ready for next time. Okay, if you have any questions, just post it in the comments or you can ask me in class.